A student let us solve the following problem. They say that a submarine carries an oxygen tank that holds oxygen at a pressure of 100 atmosphere. What must be the volume of the tank to provide liquid oxygen for 50 people for 10 days? Assuming the daily energy expenditure is 2,320 calories per square meter and the average surface area of each person is 1.70 meters square. Well, the first you have to remember to solve a problem like this one is that exists a relation between the number of calories of energy that are produced in corresponding with the number of liters of oxygen that we are consuming. So we know that approximately 4.83 calories of energy are produced by liter of oxygen consumed. By 1 liter of oxygen consumed. So basically, to solve this problem, where we need to know what is the volume of the tank where we are uh, holding this oxygen, we must find what is the total number of calories that are consumed by these 50 people during the 10 days. If we are assuming, and this is a value taken from chapter 11 of the book of Paul Davidovich, um, that the daily energy expenditure for a person is 2,320 calories per meter square. Uh, Meter square because it's the surface area of the person, and that the average surface area of one person is 1.70 meters square. So what else I know? I know this relation between the number of calories of energy that we produce and the number of liters of oxygen we are consuming to produce those calories. We know that the pressure of the tank, the oxygen into the tank, is 100 atmospheres. We don't know the volume of the tank, right? We know the number of people that are in the submarine. We know there are 50 people. We know for how long they will be there. So the time will be 10 days. And we know the surface area of a person, the average surface area of a person, that we know that is 1.70 meters square. And what else we know? We know the total energy expenditure of one person per unit of area. During the day, that should be in the order of 2,320 calories per meter square. Well, with all this information, the first we're going to do is to calculate what is the total number of calories, that those 50 people during these 10 days are going to be consuming, you know. So we say that 2,320 calories per meter square, that is, the energy expenditure for one person, uh-huh, uh, multiplied by the average surface area of a person, that is 1.70 meter square per person, times the number of persons that are 50 persons here, times the number of days, right? that are 10 days. And remember that regardless, that in the book they don't give you this unit, they don't give you day here below. This is in the denominator we have day meter square because this is the daily energy expenditure. So there is implicit here a unit of day, a unit of time. There is a day here in the denominator of this value, of this amount of energy. So if we simplify, we're going to simplify this meter square with the meters square over here, the person with the person here, days with day, and the output unit here will be in calories. So this will be the total number of calories that these 50% are going to be consuming during 10 days, right? If we are assuming that the average area, surface area of a person is 1.70 meters square. So that gives a total of 1,972,000 calories. So this here, is the total number of calories, that these 50 people are going to be uh, consuming for 10 days. Now, we're going to find the number of liters of substance that are needed, right, to be able to produce all these number of calories. So we say that this 1,972,000 calories times 1 liter of oxygen every 4.83 calories. We simplify the calories and we get that they will be consuming 408,281 liters of oxygen. Once we know this number of liters of oxygen, we're ready to find what is the volume of the tank. And then let us do the following analysis. When I have the oxygen here, as I said, well, let us then, analyze uh, the pressure and volume, in each case. So here is the submarine. And here is the tank where we are holding the oxygen. So what we know that the pressure in this tank is 100 atmosphere. And what we want to find is just the volume of this tank that we call volume 1. The volume of this tank is going to depend, right, in the volume of uh, oxygen that we need, that is this 408,281 liters of oxygen, that we need just for these 50 people during the 10 days. So in the submarine, the pressure will be 1 atmosphere, and then we're going to have the consumption, of oxygen here that is over 408,281 liters. So what we want to know is what is the uh, volume of the tank that is going to be able to hold all this volume of oxygen, if we have a pressure in the tank of 100 atmospheres. So that's why we say that the product of the pressure times the volume, is constant. So P1 B1 is equal to P2 B2. So what is P1? Is the pressure into the tank, that is 100 atmospheres, times the volume of the tank that we don't know, equal to the pressure in the submarine, that is 1 atmosphere, times the volume of oxygen that we are going to be consuming. You know, that is 408,281 liters. If we solve for B1, this will be 1 atmosphere times 408,281 liters divided by 100 atmospheres. So when we make the conversion, we're going to have this is equal to this volume 1 is equal to 4,082 liters approximately. But we can convert now these 4,082 liters into cubic meters. So to make the conversion, we say 4,082 liters. That is the volume of the tank, right? But we're going to convert these liters into cubic meters times we have 10 to a negative 3 cubic meters in 1 liter. But we have 1,000 liters per cubic meter, right? So we're going to simplify the liters here, and then we get here 4.08 cubic meters. So the volume of the tank, right, into the submarine, where we are holding the oxygen at 100 atmosphere, the oxygen we're going to be consuming for the next 10 days. You know, all the 50 people that are in the submarine are going to be consuming for the next 10 days, right? This volume is equal to 4.08 cubic meters. So in a tank with volume of 4.08 cubic meters at 100 atmospheres of pressure, we're going to be able to hold up the oxygen that these 50 people need during 10 days, you know, to be there in the submarine. So it's a very interesting problem. I hope you know that this problem is going to help you to understand better, you know, the topic we are explaining. So thank you for your attention.